Before we go delving into the details of code-level security, the first question we should ask is, well, what is it? The question that code-level security asks is, can a piece of loaded code execute a specific action? So for example, is a specific piece of code allowed to read from or write to a file? And does it matter where that file is located? So it might be the code has rights to read from or write to a file in the user's home directory, but it doesn't have rights to read or write a file in the system directory, let's say. Also, should a piece of code be allowed access to the network? Traditionally in the Unix world, code is allowed access to sockets with a port number above 1024, but not to ports that are numbered below that. So what about Java code? Should we give it the same access? Should we change the access? And should that access depend on which directory or which network location the code was loaded from? Why do we care about this? Why is this important? So Java code is mobile. Originally, Java was meant as a language that allowed us to write mobile applications that were loaded inside a web browser, these things called applets that nobody ever uses these days. But that's why this came around. Applet code was loaded across the network by definition. We were loading code from a remote server. But even now, we can load Java code from anywhere. So Java code can be loaded across the network. And as we're loading different pieces of code, different libraries from different locations, we might want to prevent some of those libraries doing certain things. We don't necessarily trust all the locations code could be loaded from. So we'd like to limit what code could do depending on where it gets loaded from. It's also possible that we might just trust certain libraries less than others. So for specific libraries, we want to lower a trust level. So you can say for library A, it can do anything we want to. For library B, it can only do certain things. By doing this, we reduce the surface area for any attack. By restricting what code can do, we restrict what attackers can do, at least in theory. This is known as the principle of least privilege. So any piece of code should only be allowed to do the things that we think it should do. It shouldn't be allowed to do anything within the framework. Now, security within Java has a long history. We just said Java was designed to be mobile, so security was built in from day one. However, initially, the way security was implemented was by running code inside this thing called a sandbox. So essentially, any application running inside that sandbox was restricted to the things the sandbox would let it do. So we couldn't decide if a piece of code was loaded from one location, it could read files. If it was loaded from another location, that it could read and maybe write files. It was purely down to the way the sandbox was written. And as you can imagine, this was very inflexible. So when Java 2 came out, we changed the model. And we changed the model to allow us to determine which code could do what depending on location, i.e. depending on where that code was loaded from. So in Java security, there are three principal players. Permissions. So is code allowed to perform some operation? So code may have permission to read to file, write a file. It may have permission to write to a socket. It may have permission to do many things within the framework. We have a permission for each of the things that we might want code to be able to do. Then there's policy. So we need a way of configuring externally to the application these permissions. So if I know there's a read file permission, how do I configure that for my particular application? And that's all done through a policy file. And then finally, how do we enforce this? So if a piece of code violates some policy, then we should not be able to ignore that violation. And Java does this by throwing security exceptions. So if according to policy, I don't have a permission for a certain action that I try and perform, then there'll be an exception thrown by the runtime. In the next module, we'll take a look at these three pieces in slightly more detail.